We are a vehicle manufacturing company.
We've been tasked to design and manufacture a small-scale, low-carbon emission cargo vehicle that must travel a 1 meter, 10-degree inclined surface in under 30 seconds with weight.
After looking through design textbooks, published articles, and various different reports, we expanded our understanding of the basic functions of our vehicle and obtained ideas to best achieve our objectives.
Firstly, we looked into tire grip, as to get across and up the incline, with the tires needed sufficient traction. Through further research to meet our functions and achieve our objectives, we found that we needed to increase the torque of the car. To do this, we must upgrade our motor. The key findings of our research were 1. Improved tires to maximize traction, and 2. A motor with greater power.
After all the group and advisory meetings, we've came up with 5 different design alternatives. So this was our selected design, a 250 by 200 millimeter block of Lego. We have a Lego wall, a wood cylinder, and 3D printed components for the axles. The wheel and axle were stock, and here we have the motor, which we upgraded, and gears, which we also upgraded.
With this, we began to work on our working drawings.
After getting our drawings approved by Dr. Agucha, we headed to the lab.
And it's, hello. You guys answer.
Yeah, but I thought you would measure it yourself. You were wondering if the
Rivals working together. At the Fab Lab, we realized our entire width had to be under 200 millimeters, not just the base. So we narrowed the base width to 100 millimeters and kept on going. That's until we got an important announcement on Canvas. We could no longer use the Lego we brought, and we couldn't afford it in our budget, so we needed a new base.
We had 2 options, a wooden base or a 3D printed base.
Well, we couldn't use the 3D printed base because of carbon emissions, so we had to use the wooden base.
So for our design, we have a wooden base, we have our motor and our gear set that we purchased with our $25 budget. We 3D printed a housing for our motor and axle holders on the bottom.
We ran into 2 main problems. Our motor was too powerful for these gears. That's why the gears slipped and caused the car to not move up the ramp, although it did move across the floor. Next, we had to put this 3D component here so that the teeth of the gears aligned. Our first problem was fixed very easily.
With a 3D printed motor holder. Having this problem, we decided to conduct some more tests. Unfortunately, it didn't go so well. Sometimes the car would make it up, but sometimes it definitely wouldn't, and definitely not with the weight. This was because our gear ratio and the RPM of our motor was not aligned. And due to the time crunch, we weren't able to implement anything else. And so unfortunately, at the competition, our car did not make it up the ramp.